Good morning, ladies and gentlemen. I'd like to quickly introduce myself. My name is Hany Windri Astuti from Polytechnic Negeri Semarang. This morning, I'd like to present our findings on 5G-NR channel model performance in Semarang City based on 3 weather conditions. Today, I will be covering 5 points on the outline. Those are motivation behind this research. The second is the problem identification, and finally is conclusion. Ladies and gentlemen, I'd like to share this research motivation to begin with. It had been predicted that in 2020 and beyond, the internet network serving more than 50 billion devices is the main leading cause of elevating cellular network communication. Thus, large volume of traffic is needed, and thereby, high bandwidth and low latency are indispensable. Those prerequisites are the principle of 5G-NR technology. Now let's move to the next part, that is the problem identification. A major issue of 5G-NR is channel model. Channel modeling is very important in wireless communication system because the capacity produced depends on the channel. And also, it must consider environment parameter. Nevertheless, few studies have been published on the channel modeling in complete weather conditions. Our research aimed to find the performance of 5G using real fields parameter and using the input in the weather conditions. Ladies and gentlemen, let's move to the method. We modeled the channel using NYUSIM software. It is a channel simulator developed by NYU Wireless or New York University Wireless. Besides, we also use MATLAB for the statistical process. We adopted numerology 3 from 3GPP or third generation partnership project with a frequency of 28 GHz and 100 MHz bandwidth, and the scenario was urban micro with environment of non-line of sight. We also used a Rayleigh Fading channel with rate of 1, or it is uncoded. Our novelty is that we used 3 criteria in very heavy rain, moderate rain, and no rainfall with the data from BMKG and sensors. BMKG is a Indonesian Meteorological and Climatological Station. And this BMKG we use is the station located in Semarang. The parameters we adopted in this research are temperature, humidity, air pressure, and rainfall. The reason behind the data collection is because these parameters affect attenuation at high frequency and they are interdependent. The data were got from BMKG in period of 2018 and sensor for 30 days measurement. Ladies and gentlemen, let's take a look at the flowchart. Instantaneous PDP is one of the ways to give a statistical description of time delay on multipath. Instantaneous PDP or power delay profile is then performed spatially averaging to obtain short-term PDP. The purpose of doing averaging is to immerse the variation of rapid fading. Furthermore, the averaging process is carried out spatially so that it produced representative PDP, which is also called long-term PDP, which is a signal receive power over a multipath channel. Representative PDP value in the 5G channel modeling were converted from decibel or dB to numeric, or also known as normalized as EBN0 value. The time dispersion parameter was used. The calculations are mean excess delay and RMS or root mean square delay spread. Then the simulation was done using MATLAB. Ladies and gentlemen, let's take a look at the results of the questions. That is the representative PDP of very heavy rain in BMKG data and the sensor. Here is the example, ladies and gentlemen. The representative BDP with BMKG data obtained 9 paths and root mean square in 24.6 nanoseconds. Against the BMKG data, the results of path obtained with sensor data get 8 paths with an RMS in 26.4 nanoseconds. Well, ladies and gentlemen, the results and discussion of our data is actually comprising outage probability, bit error rate, and frame error rate. And this one is the results from BMKG data. The figures on the left shows the results of outage probability validated by frame error rate. Theoretically, the value of outage probability in very heavy rain is 10 to the power of minus 5 with the power in 18.3 decibel, and its validation using frame error rate obtained 10 to the power of minus 1 with the power in 22.2 decibel. Quite some results are shown in moderate and no rain condition with just slight differences. The figures on the right shows the value of bit error rate. Bit error rate of CP-OFDM was performed using 5G complex binary phase shift keying or 5G CBPSK. The bit error rate in very heavy rain condition shows the value of 10 to the power of minus 3 with power in 24 decibel, and this is same in the moderate and no rain criteria. Against it, the value of 5G CBPSK obtained 10 to the power of minus 3 with power in 22.65, 22.6 decibel, and 23.5 decibel respectively. Ladies and gentlemen, the value of capacity is more than the rate, meaning that the channel is working in sending information, but an error still occurs. Ladies and gentlemen, let's take a look at the second result from the sensor data. I'd like to bring your attention to these figures. Figure on the left shows the outage probability that, in very heavy rain condition, the value of outage probability is 10 to the power of minus 3. And after validated using frame error rate, the value changed into 10 to the power of minus 1 with 22.1 decibel. Comparing to that of BMKG data, the outage probability of sensor data has lower value, and 10 to the power of minus 3 also exists in moderate and no rain. Well, next, the figure on the right shows the results of bit error rate. Those values are lower comparing to the theoretical using BPSK. The difference between theoretical outage and frame error rate is acceptable because the channel model is done uncoded, namely with rate in 1. Because the difference in value will be taken into account when it uses strong capacity achieving code. It appears that BER or bit error rate value of uncoded 5G CP-OFDM tends to be the same as bit error rate performance theoretically, but it is slightly better due to the multi-path fading effect of 5G channel modeling. The results of all conditions indicates that the bit error rate value practically or CP-OFDM bit error rate is below theoretical bit error rate. We found that the number of paths generated in the channel monthly is 9 in the highest RMS of 26.4 nanosecond in very heavy rain. Second, it can be inferred that the channel can work in either very heavy rain, moderate, or no rain condition, though error is still possibly there. Well, ladies and gentlemen, that's wrap my presentation. It's been an honor to be among such accomplished individuals and be able to present our research to you all. Thank you very much.